Today we're starting Unit 6 on quadrilaterals. And we're going to start with Lesson 6.1, the angles of polygons. A polygon is a closed shape with 3 or more sides. It has to close and has to have 3 or more sides, and each of those sides is a straight line segment. So something like this could be a polygon. A triangle is a type of polygon, and so on and so forth. It can have as many sides as you want, but at least 3, and they have to be, each side has to be straight. So let's start with our warm-up here, and we have some algebra problems here. So go ahead and pause the video and take a moment, a couple of minutes, to do these warm-up problems. So this first one, -20 equals -4x minus 6x. We're going to start by combining the like terms since both of these have x in them. I get -20 equals -4x minus -6x. I get -10x. Divide both sides by -10. -20 divided by -10 is 2. So x is 2. The second one, 6 equals 1 minus 2n plus 5. I'm going to start by combining my like terms on the right-hand side. I have a 1 and a positive 5. So 6 equals 6 minus 2n, since 1 plus 5 is 6. I'm going to subtract 6 from both sides. I get 0 equals -2n. Divide both sides by -2. 0 divided by -2 is just 0. So n is 0. I am fine as long as my 0 is on the top. So like 0 over -2, that's fine. It's just 0. It's not fine if we have our 0 on the bottom. My 0 was on the bottom, we would say undefined, because we cannot divide by 0. Remember, dividing is all about putting things into groups. And in this example here, 0 over -2, I'm saying I'm putting 0 items into -2 groups. So each group would get 0 items. That's why it's 0. But in the second example, where my -2 is on the top, I'm saying I'm putting -2 items into 0 groups. Well, I don't have any groups to put them in, therefore it's not possible. Our third example, 8x minus 2 equals -9 plus 7x. We need all of our variables, our x's on one side and all of our numbers on the other side. So I need to do some rearranging here. I'm going to start by subtracting 7x from both sides. I always like to start by moving my small variable, in this case the 7x, to the bigger one. 8 minus 7x is just 1x, or x. I get x minus 2 equals -9. Add 2 to each side, and we get x equals -7. And the last one here, a plus 5 equals -5a plus 5. I'm going to start by subtracting a from both sides. I get 5 equals -6a plus 5. Subtract 5 from both sides. 5 minus 5 is 0 equals -6a. Divide both sides by -6. 0 over -6. Well, 0 divided by anything, just like up here, it's still 0. So a is 0. Now let's take a look at polygons. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. Let's look at this word non-consecutive. Well, in that, the word consecutive means one right after the other, such as 1, 2, 3. These are consecutive numbers because they're in order. So what does it mean to be non-consecutive? Non-consecutive would be things not next to each other, not in order. So non-consecutive vertices, let me erase this here so that I can write underneath it, are not next to one another. Now, if we look at our diagonals here, to be a non-consecutive vertices, I want to be able to go from one vertex to the other without being on the edge of my polygon. So let's look at the triangle. Here's my vertexes or vertices. I want to be able to go from one to the other, but if we look at the triangle, if I go from one vertex to the other, I'm always on the edge of it. I'm on one of the sides of my polygon. If I try this one, I'm still on the edge of my polygon. So it doesn't work. I don't have any diagonals in a triangle. What about the quadrilateral? On the quadrilateral, we do. We can go from this vertex to this vertex, and we have a diagonal. We have one diagonal there. Now, some of you may be looking at this going, but can't I go the other way too? I could go from this one to this one, and I'd have two diagonals. Yes, you're correct in that we can go the other way as well. But when we're looking at our diagonals of a polygon, I want diagonals that do not overlap one another. So I'm not going to draw the other one, because to do so, I would have to cross my first diagonal there. So quadrilateral, we say it has one diagonal. A pentagon has two diagonals, because if I start drawing the other ones, I'm going to cross myself, and I don't want to do that. A hexagon has three diagonals. A triangle has three sides. A quadrilateral has four sides. A pentagon has five sides. And a hexagon has six sides. So in each case, we added one side to get to the next polygon. And if you look, we get one more diagonal in each of them. So let's take a look at a couple things. We're going to fill in this table, and since the sum of the angle measures of a triangle is 180 degrees, and this is something we've established before, we can make a table and look for a pattern to find the sum of the angle measures of any convex polygon. Let's start by filling out this column right here, the number of sides. How many sides does a triangle have? It has three sides. A quadrilateral has four sides. A pentagon has five sides. A hexagon has six sides. And an n-gon, well, how many sides does an n-gon have? So when we're talking about polygons, at some point we stop giving them like official names, because we can have an infinite amount of polygons. And the reason is, if I have a triangle, well, I can make it a quadrilateral by adding one more side. I can make it a pentagon by adding one more side, and so on and so forth. We can always add one more side. So there's an infinite number of polygons. So if I have 23 sides, we just call that like a 23-gon, with this number in front being how many sides it has. So if I have a 58-gon, for example, it means it's got 58 sides. So with that in mind, an n-gon, this represents the sides. It has n sides. So we're using a variable now to represent the number of sides. How many triangles are in that polygon? Well, let's take a look. In a triangle, we just have one triangle. So I'm going to put a 1 here. In a quadrilateral, you can see that when we drew that diagonal, I now have 2 triangles. In a pentagon, I've got 1, 2, 3. In a hexagon, I have 1, 2, 3, 4. So a quadrilateral had 2, a pentagon had 3, a hexagon had 4. So how many triangles does the n-gon have? Well, let's take a look. 3 to 1, it's 2 less. 4 to 2 is 2 less. 5 to 3 is 2 less. So in each case, we're subtracting 2. 3 minus 2 gets me to 1. 4 minus 2, we get to 2. 5 minus 2, I get to 3. And so on and so forth. So the number of triangles is going to be n minus 2. We're going to subtract 2 from the number of sides. That's how many triangles there are. The sum of the interior angle measures. Well, we know a triangle has 180 degrees. So with that in mind, how many does a quadrilateral have? Well, we added a triangle. 2 triangles are going to have 360 degrees, because 180 plus 180 is 360. A pentagon, we added one more triangle. It has 540 degrees. A hexagon, we have one more triangle. It has 720 degrees. As we add a side, it goes up by 180 degrees. So every side we add to a polygon makes it 180 degrees bigger. So what if we have this n-gon here? Well, it turns out 1 times 180 is 180. 2 times 180 is 360. 3 times 180, we're taking the number of triangles and multiplying it by that 180 degrees for each triangle. So we get n minus 2 times 180 degrees. So the equation here, the polygon interior angle sum theorem says the sum of the interior angle measures of an n-sided convex polygon is n minus 2 in parentheses times 180 degrees. And we use the parentheses to preserve our order of operations, where n is the number of sides. It's also the number of vertices and the number of angles. They're all the same. If I have a triangle, for example, it has 3 sides, it has three interior angles, 3 exterior angles, and 3 vertices. They're all the same number. Example 1, a heptagon has 7 sides. Use the polygon interior angle sum theorem to find the sum of its interior angle measures. A heptagon, if we could go back to here, it's not on our list. So how many sides does a heptagon have? Turns out it has 7 sides. Oops. And it actually told us that, but we can use our list to help us too. So there's 7 sides. We know the polygon interior angle sum theorem says n minus 2 times 180 equals the sum of the interior angles. Our n value in this one is 7. So everywhere there's an n, we're going to plug in 7. We get 7 minus 2 times 180. 7 minus 2 is 5 times 180. And 5 times 180 gives us 900 degrees. The sum of the interior angles of a heptagon is 900 degrees. Example 2, we are asked to find the measure of each interior angle of a quadrilateral ABCD. Well, if we look at this, we already know angle B and angle C. It has these markings here, and remember that means that they are 90 degrees. So I know 2 of my angles. How many degrees are there in a quadrilateral? There are 2 ways to figure this out. One way is to just go back and look at that table. A quadrilateral is listed and it tells us it's 360 degrees. The other way is to use this formula, n minus 2 times 180. Our n value would be 4 because there's 4 sides. 4 minus 2 times 180. 4 minus 2 is 2 times 180 gives us 360 degrees. We know 2 of them. That's great. And I have something that represents the other 2. That's great. We know this is the whole thing. That means that 90 degrees, I'm just working my way around this way, plus 90 degrees at C, plus the x value at D, plus the 3x value at A, has to all add up to 360 degrees. That's what the interior sum theorem means. The word sum in math means the answer to an addition problem. That means this 360 is the answer to an addition problem. That addition problem is all of our angles added up. When I add all these things up on the inside, it has to equal the total. Now we're going to combine like terms. 90 plus 90 is 180 degrees. X plus 3x is 4x equals 360. I'm going to subtract 180 from both sides. I get 4x equals 180. 180 divided by 4 gives us 45. x is 45. Well, we want to know, we don't want to know just what x is. We actually want to find the measure of each interior angle. So let's go back. I already know B and C, they were 90 degrees each. D, it says it's x degrees. Well, x is 45, so it's 45 degrees. And A is 3x. So the measure of angle A is 3x, which means it's 3 times x, so 3 times 45, which means 3 times 45 is 135. So the measure of angle A is 135 degrees. And now we know the value of each interior, or the measure of each interior angle. Go ahead and pause this for a few minutes and work out independent practice number 1 and number 2. An octagon has 8 sides, so our n value is 8. All right, so let's take a look and see how we did. Find the sum of the interior angles of a convex octagon. So n minus 2 times 180. Our n value is 8, so we get 8 minus 2 times 180. 8 minus 2 is 6 times 180. And 6 times 180 is 1080. So the sum of the interior angles of a convex octagon is 1080 degrees. The next one says find the sum or find the measure of each interior angle of a pentagon as shown. Okay, so we have a pentagon, which means our n value is 5. And if you don't know that off the top of your head, you could use your table. We can also just count the sides. We've got a diagram, 1, 2, 3, 4, 5 sides. That means all of these angles have to add up to however many degrees our pentagon is. You can go back in your notes and use the table to help, or n minus 2 times 180 is never going to fail us to find the sum of the interior angles of a polygon. Our n value is 5, so 5 minus 2 times 180. 5 minus 2 is 3 times 180, and 3 times 180 is 540 degrees. That means all of these things in here have to add up to 540 degrees. I'm going to start here and go this way. I get 142, whoops, 142 plus 2x plus 3x plus 14 plus 3x plus 14 plus 2x equals 540. All we're doing here is we're writing down exactly what's written at each angle and just adding a plus sign in between them. So now we're going to combine like terms. I've got 142 plus 14 plus 14. 142 plus 14 plus 14 is 170. And then I have 2x plus 3x plus 3x plus 2x. That gives us 10x equals 540. I'm going to subtract 170 from both sides. I get 10x equals 540 minus 170 gives us 370. Divide both sides by 10, and we find that x is 37. I don't want to know what x is though. I need to know what x is, but that's not the ultimate what we're being asked here. We're being asked to find the measure of each interior angle. I already know what angle J is. It's 142 degrees. Let's go over here and find angle H. It's 2x, which means it's 2 times x. Our x value is 37, and 2 times 37 is 74. So H is 74 degrees. And if we look at angle K, it's also 2x, which tells me that angle K is also 74 degrees. Down here at angle M, we have 3x plus 14. So 3 times x plus 14. X value is 37. We're going to go ahead and substitute that in. 3 times 37 gives us 111 plus 14. And we get 125 degrees for angle M. Angle L is the exact same thing, 3x plus 14. So it is also 125 degrees. And now we have found the measure of each interior angle of this pentagon. We're going to go ahead and skip the activity. And we're going to move on and figure out how to find the measure of one interior angle of a regular polygon. So a regular polygon has congruent sides and congruent angles. So that means that all the sides are the same, and all the angles are the same. So congruent sides and angles. So if all the sides are the same, what we can do is we can use the polygon interior sum theorem, the n minus 2 times 180. And what we would do there is we would divide it by n, because if this gives me all of them added up together, if I divide it by the number of angles, it's going to give me the measure of 1 since they're all the same. And n is the number of sides. This only works, this equation right here only works when we are talking about a regular polygon. If we are talking about an irregular one, such as this one right here, where my angles weren't all the same, it does not work. So just be careful when you use this, make sure it's a regular polygon. So let's look at this example. The poles of a tent form the vertices of a regular hexagon. A hexagon has 6 sides, which means n equals 6. When the poles are properly positioned, what is the measure of the angle formed at each corner of the tent? N minus 2 times 180 divided by n is going to give me the measure of an angle of a regular hexagon, of one angle, not all of them added together. And everywhere we see an n, we're going to plug in that 6. So I get 6 minus 2 times 180 divided by 6. 6 minus 2 is 4 times 180 divided by 6. 4 times 180 is 720 divided by 6. And I get 120 degrees for each angle. So that means this angle here is 120. This one here would be 120, 120, 120, 120, and 120. Every angle is 120 degrees for a regular hexagon. Go ahead and take a couple of minutes and do independent practice 3 and 4. I'm going to give you a couple of hints here. A nonagon on independent practice 4, n equals 9. A nonagon is a 9-sided polygon. And on independent practice number 3, if you get a decimal, don't panic, go with it. It's all right. All right, let's go ahead and see how we did. So this first one says, find the measure of each interior angle of the regular 11gon that appears on the face of a Susan B. Anthony $1 coin. So our n value is 11. N minus 2 times 180 divided by n. And since our n value is 11, everywhere we see an n, I'm going to plug in 11. 11 minus 2 times 180 divided by 11. 11 minus 2 is 9 times 180 over 11. 9 times 180 gives us 1,620 divided by 11. And when we take 1,620 and divide it by 11, we get 147.272727. The 27 actually repeats forever. So I'm going to round it to 147.27 degrees. If you rounded it to 147 or 147.3, that's fine. It did not tell you what to round to, so you are fine however you chose to round that answer. Independent practice number 4. A certain company makes hot tubs in a variety of different shapes. Find the measures of each interior angle of the regular nonagon, which is a 9-sided polygon model. So our n value is 9. N minus 2 times 180 over n. Our n value is 9, so everywhere we see an n, we're going to plug in a 9. 9 minus 2 times 180 divided by 9. 9 minus 2 is 7 times 180 over 9. 7 times 180 is 1,260 divided by 9. And when we take that 1,260 and divide it by 9, we get 140 degrees. That came out a lot nicer for us than independent practice number 3 did. It's 140 degrees for each interior angle of a regular nonagon. Given the interior angle measure of a regular polygon, you can also use the polygon interior angle sum theorem to find a polygon's number of sides. So we know that the sum is n minus 2 times 180. And to find the number of sides, we equal that to the degrees given times n. So in these types of problems, you're going to be given a certain degrees, like how many degrees an angle is, and that's what goes inside this parentheses on the right-hand side. My left-hand side never changes, so let's distribute this 180 to the n and the negative 2. 180 times n is just 180 n. 180 times negative 2 is negative 360. So we get 180 n minus 360 equals the degrees given times n. Let's go ahead and figure out what n is. So we can always start right here if you want. 180 n minus 360 equals the degrees given times n. So let's go ahead and look at an example of this. The measure of an interior angle of a regular polygon is 135 degrees. The 135 degrees is our degrees given here. Find the number of sides in the polygon. Okay, so I have 180 n minus 360 equals 135 times n. My next step, I'm going to subtract 180 n from both sides. I get negative 360 equals 135 n minus 180 n is negative 45 n. It's okay that my n value is negative. I'm okay that it's negative 45. We're going to go with this. It's going to work itself out. Divide both sides by negative 45. And we get negative 360 divided by negative 45, which gives us 8. There are 8 sides when the measure of an interior angle is 135. So 8 sides, it's an octagon. This next one says, for independent practice 5, the measure of an interior angle of a regular polygon is 144 degrees. Find the number of sides in the polygon. 144 degrees is the degrees given. We get 180 n minus 360 equals 144 n. So we're just changing this number right here. Subtract 180 n from both sides. I get negative 360 equals negative 36n. Divide both sides by negative 36. Negative 360 divided by 36 is 10 equals n. So there are 10 sides. This is a decagon. So we've seen how we can use this interior angle sum theorem to find the total number, the total measure of all of the angles together in that polygon. We have used it to figure out how we can figure out the measure of one angle if it's a regular polygon. And now we've seen how we can use that to also figure out how many sides there are in a polygon. Now let's look at the polygon exterior angle sum. Is there a relation? So I have 3 diagrams here. Is there a relation between the sum of the exterior angle measures for these polygons? Let's take a look. Let's look at the quadrilateral. We have 105 plus 40. I'm just adding them all together. Plus 105 plus 110. We got 360 degrees. On this triangle here, I've got 120 plus 100 plus 140, and I find that it's 360 degrees. On this pentagon here, I've got 65 plus 111 plus 50 plus 36 plus 98, and we find that it's 360 degrees. So is there a relation on the exterior angles of these polygons? The answer is yes. They're all 360 degrees. The sum of them is all 360 degrees. And it turns out that that's true regardless of how many sides there are. So here we had 3 sides and 4 sides and 5 sides. I could have 8,234 sides. The sum of the exterior angles would still be 360 degrees. They would just be really tiny angles. So the sum of the exterior angle measures of a convex polygon with one angle at each vertex is 360 degrees. This is actually like my favorite part of this because it's a constant. It never changes. I don't have to use an equation to know what the sum is. I just know it's 360 degrees. We're going to skip the activity. And we're going to take a look at some examples. Find the value of x in this diagram. Well, we just said the sum of the exterior angles is 360 degrees. These are all exterior angles because they're on the outside. So remember, exterior means outside. So they're on the outside of the polygon. So if we add them all up, they have to equal 360. So we get 2x minus 5. I'm working around this way. Plus 5x. We're just going to slap a plus sign between each term. Plus 2x plus 6x minus 5 plus 3x plus 10. All of that together adds up to 360. Now let's combine our like terms. So I've got 2x plus 5x plus 2x plus 6x plus 3x, which gives us 18x. And then I have negative 5 minus 5 plus 10. Negative 5 minus 5 is negative 10. Plus 10 is 0, so I'm not even going to write it. It equals 360. Divide both sides by 18. And we find that x equals 360 divided by 18 gives us 20. So x is 20. And that's all it asks us to do. Find the value of x. Well, what if it asked us to find each measure? We're not going to do them all, but I want to make sure we know how to do that. So let's just take a look up here. This angle here, how big would that angle be? Well, if x is 20 and the whole angle is 2x minus 5, we're just going to substitute that 20 in. 2 times 20 is 40 minus 5. 40 minus 5 is 35. So this angle here is 35 degrees. And we would do that with each one. We would just plug in x and figure out what it is. Let's look at this example number 6. Find the measure of each exterior angle of a regular nonagon. In a nonagon, we have 9 sides. Well, I know they all add up to 360 degrees, but how do I find the measure of one of them? We want to know the measure of each exterior angle. That means I need to figure out how many each of them are. Well, to find the measure of one angle, of an exterior angle, so one exterior angle of a regular polygon is 360 degrees divided by n. It's divided by the number of sides. N is the number of sides, but remember it also is the number of angles in a regular polygon. So we get 360 divided by, in this case, 9. 360 divided by 9 is 40. So it's 40 degrees. Go ahead and do independent practice 6 and 7. I'll give you a few minutes and then we'll go over it. All right, let's go ahead and take a look at independent practice 6. Find the value of x in the diagram. I'm going to start over here and go this way. 6x plus 9x plus 2x plus 139 equals 360. Remember, if I add up all of the exterior angles, they equal 360. 6x plus 9x plus 2x. These are my like terms I need to combine. Give me 17x plus 139 equals 360. Subtract 139 from both sides. I get 17x equals 221. Divide both sides by 17, and we find that x equals 13. And that's all we were asked, find the value of x. We could take that value of x and go back and find each angle, but for the purposes of this problem, we are finished. Our last example here says find the measure of each exterior angle of a dodecagon. If you don't know what a dodecagon was, this problem was probably a little challenging. It has 12 sides. So we get 360 divided by 12, which gives us 30 degrees. So this lesson is done. That is the end of 6.1. We have learned how to find the sum of the interior angles of a polygon using the interior angle sum theorem. And we learned how to use that theorem to find the total measure of all of the angles of a polygon. We saw how we could use that theorem to find the measure of one angle in a regular polygon. And we also saw how we could use that to determine how many sides there are in a polygon. And then we also learned about the exterior angle sum theorem and how that can be used to find a variable, to find the measure of each exterior angle, and to find the measure of each exterior angle in a regular polygon. Go ahead, the homework for 6.1 is posted on Teams. It is completed through Microsoft Forms. Please follow those helpful homework hints or tips that I gave you that is posted in the general chat on Teams. Write down your answers so that if you need to go back and finish it later, remember you can't save and finish your homework later. It won't save your answers. You are only allowed one submission, so make sure that when you hit that submit button, that is what you want to submit. And don't fret if your answer isn't written exactly the same as the way I wrote it and Microsoft Forms tells you it's wrong. I will review those and you will get credit if your answer is correct. So if you wrote 45 degrees for your answer, maybe you wrote the word degrees out, but I only put the number 45 as the answer, it's going to mark you wrong. Don't worry about that, those little things. I will review those answers and we'll make sure you get credit for the points, credit for the answers that are right that you deserve credit for. If you have any questions, please email me, post it in the chat, or stop by at lunch or after school to see me and ask questions.